Right. So welcome to UV Physics Academy, and this is the bridge course of mathematics for CSIR coaching. So this is the next part, that is series and summation part 2. So here we are considering Taylor series, first one, Taylor series. So what is this Taylor series? So here we have, this is a power series actually. This is a power series in X. Power series in X. Okay. So here we have a function. Let us take f of x. F of x is a continuous function. A continuous function and differentiable. Continuous and differentiable. Continuous and a differentiable function. That means it is a well behaved function or a well defined function. So we can say sometimes analytic function also. We can say analytic function also. So everywhere in the domain the function is well behaved or well defined. That's good. Then we can expand this power series. That is we are taking expansion of f of x. So here we are having f of x expansion at a particular point, let us say at x equal to a. So this expansion is given by f of x equal to f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial into f double dash of a, I mean second derivative, and plus x minus a whole cube by 3 factorial into third derivative of f at a, like this. Okay, so we can write this in the summation form. That is we can write it as a summation x minus a whole power n, because this is the whole power 1 and first derivative, whole square and second derivative, whole cube and third derivative. That's why whole power n, and nth derivative at x equal to a. That means nth derivative of the function at x equal to a by n factorial, where n is running from 0 to infinity. Okay, so that's it. Because whenever you have taken put n equal to 0, so this is a 1 and this is also 1, and this is a 0 derivative, means no derivative, that is f of a. That's it. So this is given by this is the Taylor expansion. Okay. So here we can find this Taylor expansion at a particular point also. So this we can take it as Taylor series. For example, I have taken the expansion of f of x. I have taken the expansion of f of x at the origin. At the origin. So that means let us take the origin x is equal to 0. That means here we have the point x is equal to a, and here the point x is equal to 0. Just to substitute a is equal to 0 in the Taylor expansion. So that is our expansion is given by f of x equal to summation. So put a is equal to 0, that's why x power n, and this one as it is nth derivative, put a equal to 0. Here the 0 is nothing but here a equal to 0. Just to substitute a equal to 0 in the Taylor series. That is 0 here divided by n factorial, and n is running from 0 to infinity. So if you expand this, it will be f of 0 plus x, because x minus a here, a is equal to 0 now, that's why x, and f dash of 0 plus x square by 2 factorial, f double dash of 0 plus x cube by 3 factorial, and f third derivative of f at x equal to 0. That's it. And this series we call it as a Maclaurin series. Maclaurin series. Maclaurin's, okay, spelling, Maclaurin's series. So Taylor series and Maclaurin series. So what is the difference? Taylor series is at x equal to a, that means other than the origin. Maclaurin series is a simple, this is expansion of the f of x, that is a power series of f of x at the origin at x equal to 0. That means just take the Taylor expansion and substitute a equal to 0 there. Okay, come on. So finally here we have the expansion of f of x. Okay, so here we have taken two cases. The first case is at x equal to a. Just let me write one more time. This is the expansion at x equal to a other than origin. I hope you remember f of x equal to summation x minus a whole power n and nth derivative at x equal to a, nth derivative of f at x equal to a by n factorial, where n is equal to 0 to infinity. And if you take the expansion at x is equal to 0, that means origin, then your f of x is equal to, just put a equal to 0. That's why summation n is equal to 0 to infinity, and that is simply x power n and nth derivative of f at x equal to 0 by n factorial. So please remember, so Taylor expansion at x equal to a, f of x equal to summation over n x minus a whole power n, nth derivative of f at x equal to a by n factorial. If you want to find at x equal to 0, that is a Maclaurin series, that is at the origin, that is f of x equal to summation over n and x power n f nth derivative of at x equal to a by n factorial. Just simply substitute a equal to 0. Let me take a few examples. I would like to find the Taylor series of, let me take one problem. I want to find a Taylor series of f of x equal to sin x at x equal to pi by 4. At x equal to pi by 4. Are you ready? Yeah. So very simple. First take the given function f of x is equal to sin x. So if you see the expansion, we want these terms f of a, f dash of a, f double dash of a, f triple dash of a, so on. So that means what? Here f of x is given. So simply find f of a. Here a is a pi by 4. So f of pi by 4 equal to sin pi by 4, which is equal to 1 by root 2. Next one. Take one time derivative, that is a cos x, and again substitute in the first derivative pi by f dash of pi by 4, that is a cos pi by 4. How much? 1 by root 2. Again one more time derivative, f double dash of x equal to, this derivative is minus sin x. So this is f double dash of pi by 4 at pi by 4. So simply take this and substitute here, that is a minus sin pi by 4, which is equal to minus 1 by root 2. And like that, just find a few terms, triple derivative also I am finding. So this is a minus again cos x, and a triple derivative at pi by 4 is again minus cos pi by 4, and which is equal to minus 1 by root 2. So once you got all these things, first write the Taylor series of formula, that is f of x equal to f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial into f double dash of a and x minus a whole cube by 3 factorial and triple derivative of f at x equal to a. Now simply substitute whatever, everything you got already. So here we are finding the expansion at x equal to pi by 4. So that's why your a is a pi by 4. So that's why this is nothing but f of pi by 4. How much? 1 by root 2. I hope you understand. This is f of pi by 4 already there. Plus x minus a. A is nothing but pi by 4. Just substitute in the formula. And f dash of a, here it is 1 by root 2. Next plus x minus pi by 4 whole square by 2 factorial, double derivative. So this is the double derivative, minus 1 by root 2. Okay. And the next one plus x minus pi by 4 whole cube by 3 factorial. And now the third derivative is here, that is again minus 1 by root 2. If you want, you can simplify by taking common or something like that, or otherwise you just leave that. So that's it. So take the function and substitute the point, keep it aside. First derivative, substitute the point. Second derivative, substitute the point. Like that, find few derivatives, 3 or 4 derivatives. And after that, Taylor series, f of x equal to f of a plus x minus a f dash of a plus x minus a whole square by 2 factorial f double dash of a plus x minus a whole cube by 3 factorial f triple dash of a, so on. Just substitute. Come on. Right. So I hope you understand this, and let us take another one more question. We will do it in a different way. Okay, ready? So the question is, they are asking what is the Taylor expansion of f of x, which is 1 by x square. F of x equal to 1 by x square at x equal to or about x equal to minus 1. Now listen carefully. So this is the second question. Good. Okay. So yeah, same process. Let us take f of x equal to 1 by x square. Don't substitute, just leave it, just listen. Now here we have f dash of x is equal to, this is minus 2 by x cube, minus 2 by x cube. 1 minute, let me see the question. Yeah, it's fine. So same, f of x equal to 1 by x square and about x equal to minus 1. So we will do it in a different way. So f dash of x is equal to minus 2 by x cube. So can you please tell me what is the second derivative of f? So this is given by minus 2 into minus 3 by x power 4. Okay. So this is nothing but simply 2 into 3 by x power 4. And one more time let us do the differentiation. So then this will be 2 into 3 into this minus 4 will be here, that's why minus 4 by x power 5. Now carefully observe, this is the third derivative and here you have x power 5. This is the second derivative, you have x power 4. Third derivative x power 5, second derivative x power 4. So what will be the nth derivative? Second derivative x power 4, third derivative x power 5, third derivative x power 5. So nth derivative x power n plus 2. That's good. Okay. So here what we are doing is, after doing some differentiations, we are trying to write the nth derivative directly. Okay. We are trying to write the nth derivative directly. So directly we will substitute in the expansion. That is a summation over n x minus a whole power n, nth derivative of f at x equal to a by n factorial. Okay. Now ready. So first see the denominator. So third derivative x power 5, second derivative x power 4, first derivative x cube. That's why nth derivative x power n plus 2. That's clear. Okay. And after that, see here the no derivative, first derivative minus, second derivative plus, third derivative minus, first derivative minus, second derivative no minus, plus, third derivative again minus. So odd numbers minus. Whenever odd numbers are negative, simply minus 1 whole power n. Sorry, if even numbers are negative, minus 1 whole power n plus 1. So if the odd numbers, odd terms, that means odd derivatives are negative, first derivative negative, third derivative negative, fifth derivative negative, that's why minus 1 whole power n. I hope you got it. That's good. And after that, next one. See, this is the third derivative. So 2 into 3 into 4. I hope you can write this as minus 4 factorial by x power 5. What do you say? And this can be written as 3 factorial by x power 4. And this can be written as minus 2 factorial by x cube. So, first derivative 2 factorial, second derivative 3 factorial, third derivative 4 factorial, nth derivative n plus 1 factorial. So, the nth derivative of the f is given by minus 1 whole power n plus 1 factorial by x power n plus 2. Now, I am taking the formula, that is f of x. Let me write here. So, the formula is f of x equal to summation over n x minus a whole power n into, this is the nth derivative of f at x equal to a by n factorial. Just to substitute. Your a is what? Minus 1. Here your a is minus 1. Take it and substitute. That is summation over n x minus a, minus of minus plus 1 whole power n. And here nth derivative, here already nth derivative is there, but x is equal to a. Here your a is a minus 1, and wherever you have x, just to substitute minus 1. Ready? So minus 1 whole power n into n plus 1 factorial divided by, so here already n factorial is there. Come on. So this is x power n plus 2. Now put, you have to substitute x is equal to a, but a equal to minus 1. That's why minus 1 whole power n plus 2. So this minus 1 whole power n plus 2 can be written as minus 1 whole power n into minus 1 whole square. That's why you can cancel this minus 1 whole power n and minus 1 whole power n. After that, minus 1 whole square will be there. That is already plus. So finally, we have the summation x plus 1 whole power n into n plus 1 factorial by, here n factorial in, that's it. And we can simplify in another way. One more term we can simplify. Because this is a n plus 1 factorial, it can be written as n plus 1 into n factorial. Yes, 5 factorial can be written as 5 into 4 factorial. 10 factorial can be written as 10 into 9 factorial. N plus 1 factorial can be written as n plus 1 into n factorial. So this n factorial gets cancelled. So finally we got, here I am writing. So finally we got, this is summation x plus 1 whole power n into, here we are having n plus 1. And the denominator term is also gets cancelled. Is that clear? So we will do one more problem. First write down. So I will write here, that is f of x 1 by x square at x equal to minus 1. The expansion is given by f of x is equal to summation over n and n plus 1 into x power n plus 2. Sorry, x plus 1 whole power n. That's it. N is equal to 0 to infinity. This will be the answer. Right. So let us take this next question. F of x equal to log x is asking the expansion of log x at x equal to 2. So listen carefully. Here the given function f of x equal to log x. First problem we have done, we have taken the function and substituted the point, and first derivative substitute, second derivative substitute, and we have written the expansion and we have done that problem. Second problem in a different way we are doing, and third one also I think this is the third question. Okay. So let me find f dash of x. Can you please tell me? Log x differentiation is 1 by x. And f double dash of x, second derivative, minus 1 by x square. Oh, first derivative plus second derivative minus. Now third derivative is simply minus of minus, that is a 2 by x cube. And let us find fourth derivative also if you are not understanding. So this is a minus, because minus 3 will go to the numerator, into 3 by x power 4. Cool. Now we have to write the nth derivative by using this one. Okay, let me write. Now nth derivative of this function. Now see carefully. Fourth derivative x power 4, third derivative x power 3, second derivative x square. First write the denominator ma. So that's why nth derivative x power n over. Next give the sign. So first derivative plus, second derivative minus, third derivative plus, fourth derivative minus. So odd numbers plus, even numbers minus. That's why minus 1 whole power n plus 1. If odd numbers negative, even numbers plus, then take minus 1 whole power n. Reverse. Odd numbers plus, even numbers minus, then take minus 1 whole power n plus 1. That's it. And after that, this is the fourth derivative. So we can write this as minus 3 factorial by x power 4, and this is a 2 factorial by x power 3. See? Fourth derivative 3 factorial, third derivative 2 factorial, third derivative 2 factorial, fourth derivative 3 factorial, nth derivative n minus 1 factorial. That's it. Now we are ready. So just write the formula. F of x is equal to summation over n equal to 0 to infinity x minus a whole power n and nth derivative, okay, of f at x equal to a divided by n factorial. That's good. Now your a is nothing but here 2. So that's why summation n is equal to 0 to infinity x minus 2, because a is a 2 whole power n. Now you have to substitute in this nth derivative x is equal to 2. Come on. Minus 1 whole power n plus 1, n minus 1 factorial by x power n, because here we want nth derivative at x equal to a. I hope you understand. But your a is a 2. That's why 2 power n. If you are having a confusion, so better to write like this. Nth derivative at x equal to a, that is a minus 1 whole power n plus 1, n minus 1 factorial by a power n. And finally substitute a is equal to 2. That's good. And already here one more n factorial is there. Then how to cancel this? Okay, so here n factorial can be written as what? 5 factorial, 5 into 4 factorial. 5 factorial is nothing but 5 into 4 factorial. That's why n factorial, n into n minus 1 factorial. So these two gets cancelled, and then summation n is equal to 0 to infinity x minus 2 whole power n minus 1 whole power n plus 1. Better to write minus 1 whole power n plus 1 first, and divided by 2 power n into n factorial already cancelled, so remaining is n. Is that clear? That's it. So this is the expansion of f of x, that is a log x, where at x equal to 2. That's it. Okay, come on. So right, here I am giving you 2 problems as a homework. So I request you please try yourself, and this is the answers also given. Just check. If you have any difficulty, please contact. And here the second problem, do it carefully. So if you observe carefully here, log 3 is separated and a summation is running from n is equal to 1 to infinity. So that means in that summation, n is equal to 0 term is not included. We have written separately. Maybe there will be some reason. So I will tell you that reason. A negative factorial does not exist. That's the only one reason. Okay. So that's why they have separated that first term n is equal to 0 separately, and after that they have written the summation for n is equal to 1 onwards. Okay. So try yourself. Please don't neglect. Next, Maclaurin series. So I have already explained. This is nothing but the Taylor series. Okay. This is the expansion. That means this is the expansion of f of x, expansion of f of x at x is equal to 0. That is the origin. Now let me try it one more time. F of x is equal to f of 0, sorry, plus x into first derivative of f at x equal to 0 plus x square by 2 factorial and double derivative, second derivative, and plus x cube by 3 factorial and a third derivative, so on. You can write in the summation form also. That is the summation x power n and nth derivative at 0 by n factorial, where n is equal to 0 to infinity. That's it. This is a very important. Let me take one problem. So here in many areas of physics, we will use e raised to x, e raised to minus x, cos x, sin x, log x, something like that. We will use many areas. We will use this Maclaurin series. Okay, let us find one by one. So here I am taking e power x expansion at x equal to 0. This is a default because we are finding the Maclaurin series, that is the expansion at x equal to 0 only. No need to mention specially. Good. So this is the, what is the expansion? Fine. Now ready. So here your f of x is equal to e raised to x. Let us follow the first method, whatever we have done. So f of 0 equal to 1 and first derivative e power x derivative is e power x only. If you differentiate e power x for 100 times, you will get again the e power x only, same function, no change at all. So f dash of 0 is also equal to 1 and first second derivative is also e power x, and if you substitute 0 you will get 1 and so on, so on, so on. Okay, now let me take the expansion now. So the formula f of x equal to f of 0 plus x into first derivative plus x square by 2 factorial and second derivative plus x cube by 3 factorial third derivative, so on. Now just to substitute whatever you got. So this is f of x is e power x, f of 0 is 1 plus x, f dash of 0 1, f double dash of 0 1, f triple dash of 0 is also 1. That's why x plus x square by 2 factorial plus x cube by 3 factorial plus so on. You can write in the summation form. This is the summation x power n by n factorial, where n is equal to 0 to infinity. So e raised to x is a summation x power n by n factorial, where n is equal to 0 to infinity. So don't forget. And now I want to find e raised to minus x. You know already e raised to x. If you want to find e raised to minus x, what you will do? Just substitute x equal to minus x. So summation over n, and this is a minus x whole power n by n factorial, where n is equal to 0 to infinity. Minus x can be written as minus 1 whole power n into x power n. So that's why this can be written as my e raised to minus x equal to summation over n. Minus 1 you can write it separately. So x power n by n factorial. So I told you, if you have minus 1 whole power n, odd terms minus, even terms plus. That means alternate plus minus. If you have minus 1 whole power n plus 1, even terms minus, odd terms plus. That's it. Okay. So finally, we got these two expressions. E raised to x equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial, so on. If you take e raised to minus x, that means alternate plus minus 1. So this is the first one, that x power 1, that's why minus x. And this is the second one, x square. So plus x square by 2 factorial minus x cube by 3 factorial and plus x power 4 by 4 factorial, so on. Right? Come on, do it yourself. So I hope you have completed. Now let us go to the next one, cos x expansion. Okay, so here your f of x is cos x. So first substitute the point f of 0 equal to 1 because you are finding the expansion at x equal to 0. Yes, you can proceed. F dash of x is equal to minus a sin x. That's why f dash of 0 equal to, it's a 0 because a sin 0 is a 0. Next, the second derivative of the function is a minus cos x. And if you substitute this point 0, then it is a minus 1. And f third derivative of x, that is a minus of minus plus sin x. But unfortunately, the third derivative at x equal to 0 is a 0. So I think, first derivative 0, third derivative 0, fifth derivative 0, like means odd powers are neglected. Odd powers become 0. So from this, we can write the expansion first. F of x is equal to f of 0, plus x into f dash of 0 plus x square by 2 factorial, second derivative, plus x cube by 3 factorial, third derivative, plus so on. I request you just substitute. Now the cos x equal to f of 0, 1. This odd powers 0. Only we left with the even powers. So next one, f double dash of 0 is a minus. That's why minus x square by 2 factorial. So third power is a 0, x cube. Next x power 4 is there. Plus x power 4 by 4 factorial. Next again x power 5 term 0 and alternate plus minus x power 6 by 6 factorial, so on. So this is the expansion of cos x. Next, try yourself sin x. So here we are taking f of x is equal to sin x and substitute f of 0, this is a 0. And first derivative, you can do along with me, cos x, and again the first derivative if you substitute, that is a 1. Okay, here the first derivative, odd derivatives are 0 and here odd derivatives are not equal to 0. Let us see, f double dash of x equal to minus a sin x. That's why second derivative, it's a 0 because the sin 0, 0. And third derivative, that is a minus cos x, and if you take this third derivative at x equal to 0, we are getting minus 1. So I hope you understand now. Even powers terms are 0 and odd powers terms are non-zero. So okay, let me write first f of x formula by using all these things. F of x is equal to formula f of 0 plus x into first derivative plus x square by 2 factorial into second derivative plus x cube by 3 factorial into third derivative, so on. So for sign expansion, we left with only odd powers and even powers are 0. So that's why here I can say sin x equal to f of 0. Unfortunately that is a 0 and this is the odd power. Yeah, it's there. So it is x. F dash of 0 is a 1. Just to substitute. And this term is 0. Similarly, fourth even power is a 0, but this is a non-zero, minus x cube by 3 factorial, because the triple derivative is here, it's a minus 1. And you can guess next x power 5 by 5 factorial minus x power 7 by 7 factorial, so on. So this is your sin x expansion. And remember one thing, whenever we are applying this small oscillation concept. Small oscillation concept means whenever you have taken a simple pendulum. Let us suppose this is the simple pendulum and it's oscillating like this. Okay. So here small oscillations means we should not take a large amplitude. That means very small amplitude. That means a theta is very small. Then only it is a harmonic oscillations. If theta is very large, then it is not harmonic oscillations, it is anharmonic oscillations. Okay, so whenever we are discussing this small oscillations, this is a very important concept we use in many areas of physics. Okay, so we will take for small oscillations. So small oscillations means here x is very small. That means you can say x tends to 0. Or x is very small. Whenever you have cos function and sine function, sir, why cos and sine functions will be there? These are harmonic functions. Okay, so that's why whenever you have sine and cos, if x is very small, then cos x is nearly equal to 1 minus x square by 2 factorial. This is a very crucial, and don't forget, and while you are discussing the Lagrangian dynamics or Hamiltonian dynamics or everywhere, many areas we will use this concept, so please remember. And similarly here sin x is also, whenever x is very small, we have to take only x. The reason is, remember, small oscillations we are taking the harmonic terms. Harmonic oscillations. So harmonic oscillations means you will be having only up to second order. So what is the reason for that? We will discuss in the main course, not here. While we are discussing linear harmonic oscillator in quantum mechanics, there we will see why second derivative we will take. Why we cannot take that, why we are not taking the higher orders. Because here you have taken up to second order means you have taken up to second derivative. That we will discuss there. So meanwhile, just remember, for small oscillations, cos x is nearly equal to 1 minus x square by 2 factorial and sin x is nearly equal to x. Because in the sine, there is no second order. For cos, 1 minus x square by 2 factorial plus x power 4 by 4 factorial, so on. Sin x, x minus x cube by 3 factorial. There is no second order term, that's why we have to take only x. Clear? Right. So now I hope you have completed. So let us take the next one. Log of 1 plus x at x equal to 0. This is very crucial, and we have already used this expression, this relation in the earlier class, that is a part 2. Okay, let us see. Now here they have given f of x equal to log 1 plus x. Let me substitute. That means log of f of 0 equal to log 1. Log 1 is 0. And f dash of x, first derivative, 1 by 1 plus x, that implies the first derivative at x equal to 0, it is 1. and second derivative of second derivative of f. So I told you 1 by f of x minus 1 by f of x whole square. That's why minus 1 by 1 plus x whole square. Again one more time if you differentiate, so the x derivative is 1 and substitute f double dash of 0 equal to minus 1. Next f triple derivative, that is here already minus is there and one more minus 2 will come, that's why plus 2 by 1 plus x whole cube, that's it. And if you substitute x equal to 0, so this will be 2. Let us find one more. So fourth derivative, this is already 2 is there and this will be minus 3. So that's why minus 2 into minus 3, that is minus 6 you can take, and by 1 plus x whole power 4. So if you substitute x is equal to 0, so here it is minus 6. Enough. So just write the formula. So that is f of x is equal to f of 0 plus x first derivative x square by 2 factorial second derivative plus x cube by 3 factorial third derivative plus so on. Now just to substitute. So here your f of x is log of 1 plus x equal to f of 0, it's a 0, and here f dash of 0 is 1, that's why x, carefully observe, f double dash of 0 is minus 1, that's why minus x square by 2, 2 factorial is nothing but a 2, and the next x cube, that means the third derivative, x cube by 3 factorial, 3 factorial means 6 into third derivative is nothing but here 2, and next one is minus x power 4 by that is a 4 factorial, 4 factorial means 4 factorial means 24 into that fourth derivative we got 6, that is minus 6, already I have taken minus here, and so on. And if you see carefully, log of 1 plus x equal to x minus x square by 2, this is x cube by 3 minus x power 4 by 4 plus so on. This is a very useful relation, so please remember. Okay, so log of 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x power 4 by 4, so on. Now in the first part we have done the last problem and we used the expansion of log 2. So here just put x is equal to 1, take it and substitute, then log 2 equal to 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus so on. So this is nothing but log 2 expansion. This is what we have used in the last problem of the series section 1, series part 1, right? Come on, take it. Right, now let us take one problem. So this was the previous question. Dispersion relation omega square equal to 2c by m into 1 minus cos ka, and is asking find omega, so at a large wavelength. Okay, 1 second. So here we have a cos function and they have given a condition large wavelength. So that means wavelength is very large. Let us say wavelength is tending to infinity because very large. You know the relation lambda equal to 2 pi by k. This is the relation between lambda and k, where lambda is the wavelength and k is the wave vector or propagation vector, something. So if these both are reciprocal to each other, as lambda tends to infinity, you can say k tends to 0. That means k is very small. If k is very small, here if you observe carefully, we have ka. So ka is also tending to 0. That means very small. Just in the last discussion we have taken, If theta is very small or x is very small, then cos x is equal to 1 minus x square by 2, nearly equal to 1 minus x square by 2. Up to second order you have to take. So that's why we can take cos Ka, because Ka is very small, cos Ka is nearly equal to 1 minus k square a square by 2. Just take this and substitute. Now, omega square equal to, this is a 2c by m into 1 minus k square a square by 2. So that 1 gets cancelled, and 2c by m into k square a square by 2. That's it. This is the omega square. So finally we can write omega equal to under root c by m, because the 2 gets cancelled, into Ka. That's it. Very simple. Okay? Come on. Just pause the video and do it yourself. Don't simply copy, try to do it yourself. And this is the next question. Just pause the video and do it yourself and finally check the answer. Now, so again here the dispersion relation is given, something. Again cos term is there. So definitely we can use the approximation. Wait a minute. Large wavelength. Again the same thing. Please do it yourself. Lambda tends to infinity. That's why k tends to 0. We can say kx, k is nothing but what? Kx x cap plus ky y cap plus kz z cap. The overall k magnitude is tending to 0, means kx, ky, kz are all tending to 0. So kxa tends to 0, as well as ky a tends to 0 and kz a tends to 0. So from all these things we can say cos kxa is nearly equal to 1 minus kx square a square by 2, because you know the relation. Cos x is nearly equal to 1 minus x square by 2 and sin x is nearly equal to x. Similarly, cos kya is nearly equal to 1 minus ky square a square by 2. So I request you, please do it yourself, don't simply copy. Is nearly equal to 1 minus kz square a square by 2. Now take all these things and substitute. Finally, omega square is equal to omega naught square, and this is a 3 minus, so 1 minus kx square a square by 2, just I am substituting, minus 1 minus ky square a square by 2, and again substitute this kz, cos kza, 1 minus kz square a square by 2. So here we have 1, 1, 1, that 3 and these 3 gets cancelled. So finally we left with omega naught square, 3 gets cancelled, minus of minus plus. So kx square a square by 2 plus ky square a square by 2 plus kz square a square by 2. So finally this can be written as omega naught square k square a square by 2. So which gives you omega equal to omega naught ka by root 2. Clear? That's it. Right. So I hope you have done this. And next, in this series, the last one is a binomial expansion. Now take a fresh page and put the heading binomial expansion. This is also very important for our CSR coaching. So binomial expansion. So what is this binomial expansion? You have studied in the 10th class. Once again recollect. X plus y whole power n is equal to, I think this is x nc0 x power n minus 0 y power 0 nc1 x power n minus 1 y power 1 plus so on. If you take that general term, that is ncr x power n minus r into y power r plus so on. Now if you write in the summation form, This is the series. Okay, if you write in the summation form, this is a summation NCR x power n minus r into y power r, where r is equal to 0 to n. That's it. So can you please tell me how many terms will be there? So whenever you are having a summation 0 to n, definitely there will be n plus 1 terms. The total number of terms are n plus 1. That's good. So what is the use of this binomial expansion and where do you apply? So first thing, we will apply this in the probability theory. Probability theory. So probability. So whenever you are talking about this probability, let us take a coin. Whenever you toss a coin, so you are having two possibilities, that is a head or tail. So whenever you are trying to hit a target, it may hit or may not hit. Or if you are playing cricket, so you may win or lose. If you are writing an exam, you may pass or fail. So whenever any event is having the two possibilities, yes or no, hit or lose, or something like that, win or lose, something, then we will apply this binomial expansion. So let me explain how it is. Now here in this binomial expansion, I am assuming let x is equal to q and y equal to p. Just reverse I have taken. So what is this p and q? P stands for favorable probability, q stands for unfavorable probability. So q stands for unfavorable probability or unfavor, and this p stands for a favorite probability. For example, if you take a coin, that p is equal to half and q is also half. Or if you take a dice problem, dice, p is 1 by 6, that means getting a number, getting your favorite number is 1 by 6. And what is the unfavored probability? Unfavorite probability, that is a 1 minus 1 by 6, which is equal to 5 by 6. That is a q. So definitely p plus q must be equal to 1. That's good. Okay, so here I am taking x equal to q and y equal to p. So then this can be written as p plus q whole power n. Capital N I am taking. I will tell you what is the meaning of that. Just x I have taken as q and y is taken as a p. So this is a summation. Okay, so small n is replaced with the capital N. Just I have taken capital N C R. Here x, our x is nothing but a q, that is x is nothing but a q power n minus r into p power r. Okay, so let me rewrite this. Summation NCR p power r into q power n minus r. So this is the expansion, binomial expansion, p plus q whole power n. Definitely this must be equal to 1. Because a p plus q is always equal to 1 in this probability theory. P is a favorite and q is unfavored. So the sum should be equal to 1. Good. Now what is this term? This is a very important. What is this term? This term indicates this is the probability, okay, and how many times you tried capital N number of trials. That means you have taken a coin, you toss it for 5 times. That means n is equal to 5. Out of that n times, how many are in your favor? See this one carefully. P stands for favor and Q stands for unfavor. That means you tried for capital N times, out of that R number of times in your favor. So the probability representation P, N, and this is R. What is the meaning of this? Probability R in favor out of N trials. Probability of getting R in favor out of capital N number of trials. This is given by NCR P power R Q power N minus R. So this is very, 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 very important. So don't forget this. Okay, come on. So once again, what is this probability? Probability of getting r times in your favor out of capital N number of tries, that is NCR P power R Q power N minus R. Let me take a problem. See this one. A coin is tossed for 5 times. So capital N is a 5. And what is the probability of getting 3 times heads? That means 3 is your favorite number. I mean 3 times you want your favorite. Your favorite is head. Okay. So you know the formula Pn R equal to n times you tried, R is in your favor. That means NCR P power R Q power N minus R. So finally here P 5 times you tried and 3 times in your favor, that is a 5C3 and P power 3 and Q power 5 minus 3, that is a 2. So for coin problem, so if you have a coin, I hope you know favorite probability P is equal to 1 by 2, Q is equal to 1 minus P, that is also 1 by 2. So this is 5C3 and P 1 by 2 and Q also 1 by 2, 1 by 2 whole power 3, 1 by 2 whole power 3. So this is 1 by 2 whole power 5. That's it. Clear? So this is the probability of whatever you want. Okay, come on. So ready? So the next one, the last one, listen carefully. So here we got the binomial distribution. One more time I am taking this binomial distribution. X plus y whole power n equal to summation NCR x power n minus r y power r, where r is running from 0 to a small n. That's it. Okay. So let us take x is equal to 1. Okay. Y equal to x. I am taking x equal to 1 and y equal to x. And remember this mod x, that means mod y. So whatever you are taking this y, this mod y, that means here it is a mod x which is a less than 1. Okay. So let me take it and substitute. Then it is a 1 plus x whole power n equal to summation NCR. Your x equal to 1, leave it, and y is nothing but x, so that's why x power r. See how simple it is. So we can write this is equal to 1 plus x whole power n equal to, this r is running from where to where? 0 to n. Now let us substitute one by one. NC0 x power 0, NC0 x power 0 is nothing but what? 1. Okay, shall I take directly? So this is 1. Next if you take r is equal to 1, NC1 x plus NC2 x square plus NC3 x cube plus so on. That's it. Okay. So here for example, you can rewrite this also. 1 plus nx, NC2 is nothing but n into n minus 1 by 2 factorial x square. NC3 is n into n minus 1 into n minus 2 by 3 factorial. Okay, 3 factorial means 6 you can write, it's okay, into x cube plus so on. Because NC2 is n into n minus 1 by 2, NC3 n into n minus 1 into n minus 2 by 3 factorial. Okay, so this is a 1 plus x whole power n. So please remember this, very, 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 very useful. Now you got a doubt. Sir, sometimes we need 1 minus x whole power n. How to find? No need to get tension. Just we want 1 minus x whole power n means here just replace x with minus x. Now start 1. That means here you are substituting x with minus x. Okay. Now restart. 1 minus nx. Here x square. That's why plus only by 2 factorial x square. Here x cube. That's why minus n into n minus 1 into n minus 2 by 3 factorial x cube plus so on. Now you got one more thing. Sir, I want to find 1 plus x whole power minus n. Take this as a standard formula and substitute n is equal to minus n. Okay, now put n is equal to minus n. Ready? So just substitute n equal to minus n. 1 minus nx, you are substituting n equal to minus n. So here it is a minus n and here it is a minus n minus 1. So you can take minus common. Then it will be n plus 1. Already one minus is there. Plus n into n plus 1 by 2 factorial x square. Next come to this. Minus n minus 1 minus n minus 2. So 1 minus common, already one minus is there. So that's why minus n into n plus 1 into n plus 2 divided by 3 factorial x cube plus so on. Now you got one more. Sir, I would like to find 1 minus x whole power minus n. Yes, in the again same formula, put x equal to minus x and n equal to minus n. Let us see. Just take this as a standard formula and whatever you want just substitute. So now here you are substituting x equal to minus x and n equal to minus n. That's why this is a 1 plus nx. And after that, here you are substituting n equal to minus n and x equal to minus x. Or simply we can say take this. I hope you are observing. Take this, okay, and here take this expansion and simply put x equal to minus x. Ready, start. X equal to minus x, that's why nx. X equal to minus x. 1 minute. Sorry. Yeah. So this one, I'm sorry. So yeah, better to take this. Take this. We want 1 minus x whole power minus n. Already 1 plus x whole power minus n you have written. So take that expansion and substitute x equal to minus x. Come on, write down 1 plus nx plus n into n plus 1 by 2 factorial. No need to change n. Only x square. And now here x cube, that is a minus x whole cube. So that is a minus plus n into n plus 1 into n plus 2 by 3 factorial x cube, so on something. So like this we can remember. No need to by heart each and everything. So just to remember the first one, that is 1 plus x whole power n is 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 by 3 factorial x cube, so on. Or simply binomial expansion, nc0 x power 0 plus nc1 x power 1 plus nc2 x power 2 plus nc3 x power 3, so on. Clear? Come on. Right. Now I hope you understand this. Let us take a small example and we will close this. Here we have a relativistic particle. That means this is the particle whose rest mass is m0 and it is moving with a high speed, relativistic speed nearly equal to c. Then its mass will be increased, that m become gamma times m0, where gamma is what? I think some of you know, no need to worry, we will explain in the main course. Gamma equal to 1 over under root 1 minus v square by c square. Okay, so that gamma equal to 1 over under root 1 minus v square by c square, just take it and then m equal to 1 over under root 1 minus v square by c square into m0. So let me rewrite this. This is 1 minus v square by c square whole power minus 1 by 2 into m0. That's it. Now just now I explained 1 minus x whole power minus n. If you are able to remember directly, please remember. Otherwise my advice always don't by heart all the things. 1 plus x whole power n equal to 1 plus nx plus n into n minus 1 x square by 2 factorial plus n into n minus 1 into n minus 2 by 3 factorial x cube, so on. I request you please take this formula, and in this formula your n is minus 1 by 2, your x is v square by c square. Just take these things and substitute and try yourself, and I will give you the answer, and please check whether you are getting that same answer or not. Come on. So right. So here 1 minus, and here also minus, of course x is equal to, x is also minus. Take these two and substitute, it's a plus 1 by 2 v square by c square. Next plus, your n is minus half, that's why minus half minus 1 minus 3 by 2 minus minus plus 3 by 2 into this one. I think this is a 3 by 4, so finally 3 by 8. 3 by 4, here it is a 2, 3 by 8. X square, that's why v power 4 by c power 4. As you go like this, then again you will get c power 6. But definitely c is a big number, I mean c is greater than velocity, definitely. So although v is a relativistic speed, v is not equal to c. That's why the higher orders will be neglected. The reason is v power 4 by c power 4, next one v power 6 by c power 6. So that is tending to very less value. That's why neglect the higher orders. Just take this, and finally m equal to m naught into 1 plus a half v square by c square plus 3 by 8 v power 4 by c power 4. So I request you, just multiply with the c square on both sides. That is mc square equal to m naught c square. Just I am splitting this, otherwise the next step we will write 1 plus v square by 2c square and plus 3 by 8 v power 4 by c power 4. Just split it. mc square is nothing but the energy, and this m naught c square is nothing but rest energy or rest mass energy, plus just multiply this and this. So half c square gets cancelled, m naught v square, and this c square and c power 4 gets cancelled, 3 by 8 m naught v power 4 by c square. So if you see carefully, this is of course rest energy, and this is the kinetic energy. This is a kinetic energy, non-relativistic kinetic energy. So this entire thing is the kinetic energy, okay? Kinetic energy of what? Relativistic particle. So this is the kinetic energy, non-relativistic, plus some correction is there. So we can say this correction, this term is the relativistic kinetic energy correction, or simply relativistic correction. Relativistic correction to the kinetic energy. That's it. Okay. So thank you, and with this we completed the summation and series 2 parts, and we will meet again in the next lecture. So I request you, please practice properly and attend only one lecture properly, and practice, and please write the notes properly. Once you are perfect with the one lecture, then only go to the next lecture. Okay, till then you just practice the present lecture only. Okay, thank you.